So in the previous video, we have seen about various types of treatment methods. In that we have seen the chemical methods. Now in the chemical methods, there was one thing about which we have not written in detail, that is the chlorine demand. So you just write it down in the note. So what exactly is chlorine demand? So when chlorine is added to water, then it is, or we can say it initially reacts with iron and manganese. So it initially reacts with iron and manganese. After this, after this, it reacts with ammonia, and forms chloramines. Okay. So first stage is it is reacting with iron and manganese. In the second stage, it is reacting with ammonia. Okay. So ammonia. After this, after these two reactions, it is finally reacting with microorganisms. Okay. So now the amount of chlorine which is consumed in the above three processes, that is the initial reaction with iron and manganese, then reaction with ammonia, and then after killing, or the amount of chlorine required for killing the microorganisms, if we add this total chlorine, then this chlorine is called as chlorine demand. So the amount of chlorine consumed, the amount of chlorine consumed during the reaction with above substances is called chlorine demand. Chlorine demand. So this is the meaning of chlorine demand. Okay, so now we are going to start with the next topic, that is forms of chlorine. So as we know now, majorly we will be using chlorine. So what are the various forms in which the chlorine is present? So in the forms of chlorine, so there are total 4 forms that we have to study. So the first form is called as hypochlorites. Hypochlorites. Second one is called as chloramines. The third one is called as chlorination gas. Chlorination gas. And the last one is chlorine dioxide. Okay, so chlorine is available in these 4 forms, and we have to study each of these forms. So let's start with the first one, that is hypochlorite. So chlorination by hypochlorites is called as hypochlorination. Now what are the 2 types of hypochlorites that are present? So 2 types of hypochlorites. So they are this. The first one is called as calcium hypochlorite. So the name is very important, calcium hypochlorite. And the second one is called as sodium hypochlorite. Now this calcium hypochlorite, this is called as bleaching powder. So now you may be remembering that this bleaching powder is used in water. Okay, so for what it is used? It is used for the disinfection. Now among these, the first one, that is calcium hypochlorite, or what we call it as bleaching powder. So it consists of about 30 to 35 percentage of chlorine. So bleaching powder consists of, so it consists of 30 to 35 percentage of chlorine. And chlorine dose is equal to bleaching powder dose multiplied by percentage of chlorine in bleaching powder. So bleaching powder dose is equal to chlorine dose is equal to bleaching powder dose into percentage of chlorine in bleaching powder. And what is the percentage of chlorine? It is around 30 to 35%. It will be given in the question. So this calcium hypochlorite, it is very economical and it produces the free chlorine. Now about this sodium hypochlorite, we won't be writing much points. The only thing that you have to remember is it consists of 10 to 15 percentage of chlorine. As the amount of chlorine is very less, it is not used in disinfection. Okay, so the main important one is calcium hypochlorite. Now start with the second one. The second is called as chloramines. Now when chlorine reacts with ammonia, it produces the chloramines. When chlorine reacts with ammonia, it produces chloramines. Now these are the four reactions that you have to remember it. So the first is Cl2 plus H2O. So this gives us HOCl plus HCl. So this we have already seen. Now this HOCl, this reacts with ammonia, that is NH3, and it gives us NH2Cl plus H2O. Now again sodium hypochlorite reacts with NH2Cl and it gives us NHCl2 plus H2O. Again this HOCl reacts with NHCl2 to give NCl3 plus H2. So these are the four reactions. Now based on the pH value, there is the formation of a particular type of chloramine. Okay, now if the pH is less than 4.4, if the pH is less than 4.4, trichloramine is formed. Trichloramine is formed. Okay, so trichloramine is formed. If it lies in between 4.4 to 5, then dichloramine is formed. Dichloramine is formed. If pH lies between 5 to 8, then both monochloramine and dichloramine are formed. And if the pH value is greater than 8, then only monochloramine monocloramine is formed. Monocloramine is formed. Now among these four names, just by the information that you have been collecting from the previous videos, can you tell which of these four you think is more powerful disinfectant? See, for disinfection means we have to kill the disease causing microorganisms or microorganisms. When it comes to the pH value, what should be the pH value so that maximum amount of microorganisms gets killed? So the pH value should be greater than 8.5, okay, or we can assume it as 8. So when this pH is greater than 8, then only monocloramine is formed. That means among these four, the strongest one or the strongest disinfectant will be monocloramine. So if we see the order of powerful amines, then the most powerful is monochloramine. Then after that there is dichloramine, and the last one is trichloramine. Okay, so based on the pH values we can judge this. Now the next method. So we have seen hypochlorites, chloramines. Now chlorination gas. Chlorination gas. So it is a pungent smell suffocating gas, and it quickly dissolves in water and produces the free chlorine. So it is a pungent smelling suffocating gas which quickly dissolves in water, dissolves in water and produce free chlorine. So the addition of this chlorination gas, or we can say the addition of the chlorine to the water, is done in the gaseous form, and rest all the shipping and storage is done in the liquid form. So the addition is done in gaseous form, and rest all operations from shipping to storage is done in liquid form. Okay, so now here one important note is there, so you write it down. So note, now we have talked about the residual chlorine. So what happens is that this residual chlorine, when it reacts with the organic substance, it forms a compound which is called as THM, that is trihalomethane. Now this trihalomethane is carcinogenic in nature. Okay, that is, it is a cancer causing agent. But we cannot just neglect the addition of free chlorine, because we have to, or we can say the residual chlorine, because it is necessary for preventing the water from further contamination. So the drinking water standards has given a certain limit for providing the residual chlorine, and that limit is that the free residual chlorine should not be more than 0.2 mg per liter. Okay, so the same points will summarize here. When residual chlorine when residual chlorine reacts with organic substance, okay, any organic substance, it forms THM. So this THM stands for trihalomethanes. So this is a compound which is formed due to reaction of this. Now this THM is carcinogenic. It is carcinogenic in nature. It is carcinogenic in nature. So drinking water standards. So drinking water standards limit the value of residual chlorine. Limit the value of residual chlorine to 0.2 mg per liter. 0.2 mg per liter. So if we just write down the specifications which are given, then free residual chlorine it should be equal to 0.1 to 0.2 mg per liter. Okay, now so going to the next one, that is the fourth one, that is chlorine dioxide. Chlorine dioxide. So this is independent of the pH. Independent of the pH. So there are no secondary problems. There are no secondary problems. And it is highly unstable. It is highly unstable. So they have to be stored. They have to be stored in a specialized container, and hence this is more expensive. So due to its instability, there are higher equipments that are used, and due to this it is expensive. Okay, so this chlorine dioxide, this is not of much important to us, so we will not do any PhD in this right now. If it is required, we can go and prepare. If it is required, then I will prepare a separate video on this. Okay, if you are interested, you can read it from the any reference book, but these are some important points that I have given. So the important ones are the first two. In fact, the first one is the most important, that is hypochlorites. Okay, now just one last thing that we will write here. So that is law of disinfection. Law of disinfection. So from this they can ask that who gave this law. So the law of disinfection is given by Chicks. Hence it is called as Chicks law of disinfection. Hence called as Chicks law of disinfection. Okay, now what is this law, or what is the statement for this? So NT is equal to N0 into e to the power minus k into T. So this is the equation which is given by Chicks, where NT stands for number of organisms remained at time t. What is N0? N0 is number of organisms initially present. Number of organisms initially present. T is called as contact time or exposure time. and K is called as disinfection rate constant. So disinfection rate constant, and the unit for this is 1 by time. Okay, so whatever the time is given, if the time is given in second, so the disinfection rate constant will be in 1 by second. Now, so write down one formula: percentage removal of microorganism, is equal to N0 minus NT divided by NT into 100. So as it is percentage multiplied by 100. So if we go for the efficiency, so efficiency we can write it as N0 minus NT divided by N0 into 100. Now we know that this NT is equal to N0 into e power minus KT. So after solving this, we will get it efficiency is equal to 1 minus e to the power minus KT into 100, where nu stands for efficiency of removal. So efficiency of removal you can calculate it now. Now what is this N0 and N0? So if we draw a curve, or we can say if we draw a diagram, so in this, on the x-axis it is representing the time, and on the y-axis it is representing the number of organisms. So initially when there is no addition of any disinfectant, the number of organisms that are present is N0. Now slowly after adding the disinfectant, what will happen? It will start killing the microorganisms, and along with the time, as the time is increasing, the number of microorganisms will get decreased. So if we take at a time t, the amount of microorganisms or number of microorganisms which are present at this time, this is equal to nt. Okay, so this nt value we can calculate using n0 into e to the power minus kt, and these are the remaining formulas. So this is it with the disinfection topic. Now there are certain minor treatment methods which we will discuss in the separate videos. However, the major portion of the syllabus of drinking water supply, or what we can say environmental engineering part 1, is completed here.